Greetings, welcome to day 45 of Project Dig. Thank you for joining. I hope you're having a good day. Project Dig is a 2D multiplayer automation survival sandbox game that I am developing entirely here on Twitch and uploading the VODs to YouTube. We're making a custom C++ game engine using some data-oriented design and entity component system. We've made some good progress, and moving on, we're now at adding in animations and specifically animation support for spine animations. Spine is a tool, and show it off here, a tool that enables you to create very advanced and complex type of animations and have them be very compact and at least low memory. Obviously there's a cost to that. We're paying some CPU time for all of it, but yeah, so that's what we're working on. We have it all loading, and we actually got something to render yesterday just before I stopped for the day. So we're going to be picking that back up and kind of digging into what are the current issues with it, how can we fix it up, and just make it better overall, because it's not that great at the moment. Has some problems. So you can see it's actually drawing this thing. So this is our character. So we have problem 1. This guy's upside down. Problem 2, I think it's scaling it to be very large, but I'm not positive about that. So I wanted to play around with that and see if the scaling is off as well. It seems large to me. It definitely seems large and kind of blurry. But yeah. So let's look at that. So one thing I was thinking of is that it might be upside down because of how we have our sprite indices. So I wanted to look at that and see if that is indeed the issue. So basically how it works is that we specify our the coordinates for both the world position as well as the texture coordinates, and so we only have 4 of those, but then we need to make triangles out of them, and so we kind of connect them up, and since we need 2 triangles to make a rectangle, it's a total of 6 indices, and I think those might be wrong. I think it's definitely possible to get it messed up where it would be flipping upside down. Do you have essential or professional spine license? Right now I have neither, but I'll be buying the professional one. I might start with the essential, but I have neither at the moment, just because I haven't actually used it yet. I don't even have Spine downloaded. Yeah. Okay, so I think that these might be off. So I wanted to look at how exactly our world vertices are being computed and see if we are calculating this wrong. So this is how we set up the world vertices. Just saw your spine folder. This right here. Yeah, this is just all the the C++ runtime. That's it. Yeah, so here it does, yeah, this is immediately I can see different. It's bottom right, bottom left, upper left, upper right. So let's try to match that up to what we were doing for our normal sprite, which is, okay, I need to write this down. Okay, so our normal sprite is, hey Steve Void, what's up? Welcome. Our normal sprite is 210320. 210320. And what it does is it's upper, it just goes clockwise from the upper left. So it's upper left, upper right, bottom right, bottom left. That's how ours is set up. Oh, I'm up all right. This coffee's kicking my butt. Nice. Yes, I'm enjoying some coffee as well. That's good. Feeling good. Feeling good. Okay, so let's see this spine sprite and how it's doing things. So it does bottom right, bottom left. Bottom right, bottom left. Upper left. Upper right. So you can see it's pretty much upside down, which is probably why it is actually upside down. So if we look at this, it's set up as 0, 1, 2, 0, 1, 2, 2, 3, 0. Wouldn't it be upside right if I just flip these? Right? Hey, Cooler, what's up? Greetings. No, that's a little unexpected. What's going on here? Kind of curious to see if I don't think so, but skeleton get bound. I wonder what the scale is being set to. Or maybe it's not being set. Maybe that's our problem. Where is that located? That's right, it's in resource. I don't set the scale. Maybe it's not initialized. Right here, the skeleton binary scale, set scale. Let's just say it defaults to 1 and see what that looks like. that. Is that really the full size? I mean, the normal size? That seems really large. Okay, let's try doing, oh wait, there's one other thing, right? There's the skeleton itself. Maybe I should try messing around with that as well. I think there's the spine skeleton, and you can set, I don't know what the set scale X and scale Y. We could try this. So I'm just playing around with that. I don't think that this is the actual issue, but yeah, let's try reducing this down. Let's just say it's like 0.5. It's weird that it looks like it's being scaled up. That looks much more, I don't know, that looks much better to me. We can actually see the character. That's nice. Okay, so let's keep playing around with this. Let's actually lower it down to like 0.3 so he can be even smaller. And then also I was going to take this and draw a rectangle around the bounds. So this is a little wasteful, but whatever. Oh, whoops. Yeah, I need this here. And then the shape is now going to be X, Y, width, and height. Transform, scale, origin, angle. The scale is going to be off. So maybe what I should actually be doing here is spine, or no, transform. And so I'm kind of breaking things here because I say I'm only reading, but that's not actually what I'm doing. Set it to 0.3, 0.3F. Okay, and then here we can set it to the transform scale X. I need to figure out how to make it so it doesn't do that anymore. Okay, so now we're setting the transform scale. And we could actually, I guess, go to, we don't need to be doing that every frame. We can go to game and set it up in there so that the transform, yeah, here we go. We can just say, hey, this is 0.3. And then up here, I think that's all good now. So it uses the transform scale. Hey, Zendiv Arts, welcome. Hello. Yeah. That's annoying. Okay. Wait, what does that want? Rectangle shape takes a pixel rect. Casting things away. Okay, that should good. So what is projectDIG? There you go. If you have any other questions, you're more than welcome to ask. Yeah, look at that. It's saying that the bounds is way smaller. That's kind of what I was expecting. Like, it says that it's supposed to be rendering here, but this is actually what we're getting. It's pretty interesting. And you see that sometimes it, like, it's really big or something. I don't know. I think I'm missing a critical point here on like rendering this. Let's take a look. Like, maybe I'm forgetting to update like, I'm not doing this stuff. That's fine. That's fine. But maybe I'm forgetting to do something up here. Like one of these things. Let's see, read it. What's the animation data? Set default mix. Set the position. Set animation. We can work on doing that as well. Apply. So am I not doing these? I thought I was, but we can double check. Hey, said who? Welcome. Yeah, so in our animation system, animation dot okay, here we go. We set the X, set the Y, get the root bone, set it by the rotation. Let's actually disable that for now. Maybe that's causing things to be weird. Oh, you know what? That could be flipping it upside down. Update the world transform. That happens here. So we call update. Wait. Apply, update. Yeah, okay, that's right. Animation state, apply, skeleton, update world transform. That seems good. Yeah, we could be flipping upside down with that transform. Maybe that's what's happening. Nope. This is being called though, right? Yes. Maybe we should look at some other stuff. Like, let's look at the bones. Size is 18, capacity buffer. I think this is the child bone. I'm not positive about that though. Looks like it. Yeah, we can see the rotation set to 0 at the moment. Scale X, scale Y, shear, skeleton. Yeah, here it says it's the root. Transform mode is normal. How does sprite sheet look for that character? So we have this here it is. We have this atlas. So this is called this is technically called an atlas page. And so you have an atlas. We should be able to open this with Sublime Text. Here we go. So this is what the atlas page looks like, or the atlas looks like. It only has one page. And it basically tells you how everything is set up. And so it reads through this, loads it, and then it knows like, oh hey, the front thigh is located at this position, and this is the size, and that's the origin, and this is the offset, and so on. And then the game, after it finishes loading the atlas, well, whenever we provide this texture loader to the atlas, so whenever the atlas needs to load a texture, or a texture page specifically, it will, an atlas page, it will be able to load it. And so it loads it, and then that's how it knows where all the information is stored. And the atlas is used to create the skeleton data. Is there a tool to create atlas from sprite image? Yeah, that's in Spriter. Oh, sorry, not Spriter, Spine. Yeah, Spine has that. So whenever you export your Spine project, it does everything for you. Yep, no problem. I'm not sure what's going on with this yet. It's updating it. You know, one thing actually I'm kind of curious about. Let's try applying an animation, set animation. I am curious to see that at play. Spine boy. So we can say if the, what is it, world contains a spine component, oh whoops, entity, then we want to get that I think that's right. Contains, yeah, that should be right. Get spine component, entity, spine, and then we need this to be spine.state, set animation. This is animation names, so we can just say walk, right? Spine string, yeah. I think that should be right. So after we create this, it should be walking, if we do this right. Okay, wait. I must have told it to not loop or something. Bool loop? No. Telling it to loop. What's up with that? State update. Let's step into here. Timescale. Float delta. So as a single track, Animation last, track, current, delta. I guess I don't know if that's I imagine it's in milliseconds, but perhaps I'm wrong. Doesn't have a next, track, last, mixing from, track, time. I guess I can look to see like what's the animation start, end, last, next, last. So what's this expecting to be passed? Oops. And then get delta time. Delta time in seconds. I see. That's the problem. We're saying that 16 seconds has elapsed. We need to take this and divide by 1,000. Right? Oh wait. No, that's the wrong way. That would be bad. That looks much better. Hey, oh, nice. Cool. Looks pretty good. Awesome. I mean, we still have a lot of issues to fix, but that's cool that we got an animation working. Good, 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 good. So yeah, I can see right now there's, I think, 3 issues that we need to fix at least. So he's upside down for some reason. Need to fix that. The sprites are being rendered out of order. And so things that should be in front are typically in back. So you can see like his visor is behind his head and like his neck is in front of his head and his knee or his legs are in front of his knees. So that's number 2. And then the third thing is I think the scaling is off somewhere or something. Because it's saying that this is the bounds, this little rectangle here. But you can see that it's actually taking up a lot more space. So that's what we're working on right now, those 3. But yeah, this looks good. That looks good. So let's actually go to this and make a static const expression float time step animation time step. I think I'll just do that. So we'll say 16 divided by 1,000. Yeah. Okay, so what do we want to fix first? we're creating little robots. Soon, Cooler, soon. Patience, my little one. Yeah, yeah, it's still going to be a while before we actually start doing development, but we're getting closer. If we look at the roadmap, like, we're gonna finish these animations. I need to work on the profiler soon-ish, and then figure out a few more things like the string hash table and our hash maps and whatnot, multiplayer scripting, and then I think that's at that point that's when we actually start moving towards more gameplay stuff. The camera and tile map, that's kind of engine, kind of gameplay, and then we really start getting into the gameplay after that point. So it's still going to be a while. Maybe I'm thinking probably another month from now or so. But yeah, not too far off. We'll see. I need to start working on Korea. I've been saying that for a while, but like I really need to. I don't want to have to stress about it. I am already kind of stressing about it, but I don't want to get to the point where I'm like really stressing about it because I have a deadline and I'm getting too close to that deadline. So the question is, am I rendering this upside down or is it being flipped upside down? The answer is I don't know at the moment. I thought I could just flip these, but I guess that doesn't actually make sense. Maybe I got the ordering wrong. Let's come back to, or get back to this here. I don't know how I could get these all flipped around, but maybe I did. So bottom right, bottom left. So 0, 1, 2 says to, and maybe I should pull GIMP. I'll get GIMP running as well. I can sketch this out. You know, now that I think about it, it doesn't make sense to flip them. That wouldn't do anything. I should have thought about that. It doesn't do anything for us. Okay. Let's make a new thing here. And let's just draw. So we have the bottom right, bottom left. Let's see here. Bottom right. Let's do this in order. Let's just get some different colors. Bottom left, upper left. Oh, upper left. And then we'll do upper right. Okay, so now I can just jump between all of these. So we have our bottom right, bottom left, our upper, oh wait, bottom right is, oh, I already got that wrong. Dang it. Bottom left would go over here. BL. Upper left is up here. And then upper right goes over here. It's not a perfect rectangle, that's okay. So then, let's see here, we'll just grab this color here, and I'm gonna make this be like 50%. Zoom in a little bit. So, this says 0, 1, 2, so 0, 1, 2 is 0, oh wait, bottom right, 0, 0, 1, 2. So that's our first triangle that we are rendering. And then it's 2, 3, 0 is the next one. So 2 would be this. So it's 2, 3 is the upper right, and 0 is the first one. So it goes like that. And this goes like that. So that's how that's been rendered. It seems fine. Like, as long as it's rendering, it should be okay, right? I don't see how this would be flipping it upside down. I guess one thing we should look at, that's actually a good point. We should look at the coordinates for those and see if they are actually like upside down. Yeah, we can just undo that, change, and just break into here. Or actually, we could break into here. Doesn't it start at bottom? Because BR is first? Yeah, but that shouldn't make a difference where it starts. I think the only thing that matters is where they're located. So if 0 and 1 indices are above 2 and 3, then that means that we are flipping it. I think that's how we can tell. I'm just waiting for that compile. What did I change that it's having to recompile everything? Hello? Oh, I went way too low. Data, here we go. 55.8. 32, negative 42, negative 33, negative 13, negative 10, 37. I guess we only really care about the second because that's the y value. So the BR is 8. BL is negative 42. BL dot y. BL dot, and then UL dot y is negative 13. So it is above it. Yeah, it's always above it. So that seems right. We can try another one. So we have a lot of regions here. So like negative 50, oh sorry, this is 58. Oh wait, this one is off, huh? Kind of. Maybe I should look at this with render doc. It might make it easier actually. Let's open this up in render doc. Okay, so we can look at what's going on here. Mesh output. Is that the one that we wanted to look at? Mesh output. It doesn't seem right. Oh, that must be for our, yeah, that must be for our, there we go, our rectangle. So this is the input. So here's all the vertices. Positions, coordinates. So one interesting thing about this is that I like vertices. This is actually seems to be upright. Can I reset that back? There we go. Put camera to geometry. Controls arcball. WASD. I'm not really messed with this. Oh, look at that. VS in, VS out. I must be flipping it in my shader. That must be it. Let's go look at our shaders. It would be our vertex shader. Right? Which means that it is our world projection. Okay, I think someone actually mentioned this yesterday, that it could be this. Or, but why would this be flipped? This is the only thing I can think of, is that it's flipped. But this is actually really helpful in that we can see exactly geometry out. Yeah. We can see that this is the in and that's the out. VS output. It must be our vertex shader, rasterizer, pixel shader. Trying to remember how to get to rasterizer, whole shader, output merger. Yeah, I don't know. We can tell that it's something with our world matrix, right? I don't know what though. I have too many files open. One sec. Actually, like drowning in Windows at the moment. Okay, that's a little better. Does spine or whatever it's called have some settings to be considered? As far as like the orientation of how that stuff is set up? Maybe. Might just be that I need to set up a different like matrix here. I don't know. Left, right, bottom, offset, up. So this is the top. This is the bottom. So just as an experiment here, what if we flip these? I need to close this. Now I can't see anything. Yeah, it gets flipped around. Okay, so maybe I don't want to do that. Well, I mean, I can't see anything. I kind of don't really know what I'm doing, to be honest. Set view transform. Oh, wait. Where's our model matrix? Maybe it's our model matrix that we need to be messing with. Identity, set transform. Thinking maybe it's the set transform I could change. I'm just trying to figure out what's going on with this. Like, why is it being flipped upside down? This is getting back to, I think it's a shader issue, really. Because we can see that the VS in is fine. It's the VS out that gets flipped. So that means that something is happening in here. But all we're doing is multiplying the vertices by the projection and view matrices. Projection and view. I think the set transform is basically sets the model matrix for the draw primitive. If it is not called, the model will be rendered with an identity model matrix. So we actually don't need that call. Good to know. So translate scale. There's probably a way to just flip invert. All of my money gone.
I'm going to farmer market.
Oh, you're going to the farmer's market. Did you want more?
No, I probably won't use that at all.
Okay. Alright. Have fun.
I'm going to drink it.
You're gonna take that?
Yeah.
Okay. Good luck. Bye.
Bye.
Okay, so let's just look around. Like, maybe we can look at OpenGL, vertex, vertices, flipped or something like that. The vertical dimensions for images in memory is inverted compared to what you need for OpenGL. I would suggest that you perform a row by row swap of the pixels in the image data in the main memory before you send it to the GPU RAM. Aren't you in D3D 11? That's a good question. Kind of forget what I'm actually doing. Init, OpenGL. Oh yeah, we are in D3D. Well, now we can be in OpenGL. Yeah, we can look at the D3D one though. Yeah, I figured it was going to be the same issue, but so maybe it is that the texture's not being loaded properly. Hmm. Yeah, it's kind of starting to sound like what the issue is. Does how you export matter? I mean, we can look at that. The format. That should be okay. How are we reading it though? That should be okay though. I'm almost positive that's okay. Otherwise our colors would be all off, right? You know, I kind of remember this being a problem back when we were first trying to do rendering, and we fixed it. And now we have this problem once more. Let the view transform. Okay, could you flip the ortho matrix and invert the culling? Kind of hack though. Yeah, I mean, sure, I could probably do that, but then I would have to, it would be flipped for everything else, so we'd have to like have it be rendered, or rendering all the spine stuff separately, right? Hmm. That doesn't seem to be right. If I knew what I was doing, this wouldn't be hard to fix. But I've maybe messed with this once before, but I kind of forget. Set view rectangle. I think I should be able to fix it with transform, right? Um, or D1. Right. It says mirroring. To get horizontal mirroring, it is required to set A equal to 1 or D equal to -1 for vertical mirroring. So we just need to flip that. So what I was thinking about doing is just trying that. I think we can experiment with that just to see if it works. Do you need help? I'm studying this right now. Sure. I mean, I welcome any help. Converting between coordinate systems. So that's talking about a relative or local, I guess, which is like for the bones and everything, to the world. So I don't think that this is actually applicable to us here. We can make sure that this is set to false. Maybe it's not. Oh, spine assumes y-axis up by default. Maybe this is wrong. Maybe that's the wrong thing. We can try that. We can say spine.skeleton set flip y. Skeletons does not have a flip y. Really? Oh, I think that's the skeleton data. Hold up. There's no set y or flip. They're lying to me. How dare they? Maybe it's on the bone? That wouldn't make sense. Look at the skeleton data. Set FPS, set images path, set flip. Linear algebra is a mind boggle, but I love the class. Yeah, I've forgotten pretty much all of it as well. Like, the sad thing is that I actually have a minor in mathematics. That's how much math I took, but I barely used it in the last decade. So if you don't use it, you lose it. So I see nothing about flipping. Nothing about flipping. I think that they're just lying to me here. I only got it because it was one more class than what was required for CS. Yeah, it's pretty much the same. It was like, for me, what it was is that I needed like one or two more classes, but I could fill those requirements as CS electives, and so I was like, sure, I'll just take like another, math class or two, and then I can have a minor in mathematics as well. Not that it really matters, but yeah. So I've taken like I took physics. I took a full year of physics. I took up to I think it was calculus 3. I took a year. I took linear algebra, and there was also another class that was similar, like that built on top of linear algebra. I forget what it was even. Then I took like statistics and all that fun stuff, and I've forgotten all of it. All of it. Yeah. Oh well. So yeah, I don't even see this. So that doesn't. I think that they're like lying. I don't know what's going on. Why do they say that there's a flip? Maybe we should look at this update world transform and the skeleton. So that's in here. Okay. So let's go look at that, because perhaps position, get Y, get X. The Y, get Y. Scaling. Maybe they just did the scale, and like instead you just do a negative number for the scale. That could possibly be it. Wait, what am I doing? This is what I want to look at. So it goes through here. Yeah, it just sets the X update. Update cache size. Update. So that's on the bone. So it ends up just calling into this. It says if this is the root bone, then yeah, I wouldn't be surprised if this was just a negative number now. We could try that for this scale. See what happens. What you doing? Is that really from setting the scale to -3? It did that? Nice. Yeah. Yeah. Ah. Why do I suck at this stuff now? Well, why do I just always suck at this? I don't know why, like, this rendering stuff just continues to elude me. So we could try messing around with the identity matrix. We're talking about doing that. Let's go look at, oh wait, what is it? BX. MTX inverse. I don't want the inverse. Multiply projection. Want to see what is this rotate? Oh, I probably want rotate Y, huh? Wait, I thought I could go view that code. Hey Yun-san, what's the problem? The problem is that our graphic is upside down. Yeah, I thought that I could be looking at that. I'm gonna open up BGFX. So the problem really is that we're passing in these vertices and we get an inverted, like it inverts it pretty much. And so I'm thinking that it's something to do with our world projection matrix, projection view world matrix. But I honestly am not like very good with that stuff, so just trying to figure it out. Okay, let's just look for MTX. Mole or something. Scale. So I think I want to set 5 to be -1. Now I'm not seeing that at all. So that just like breaks everything. I thought that I wasn't using that anywhere else. Okay, so I guess that doesn't work. I really don't know what I'm doing. Maybe the bases of the two vector spaces aren't the same. What does that mean? Yeah, I think this is too specific. Flip the order of the triangle vertices so the system traverses them clockwise from the front. In other words, if the vertices are V0, V1, V2, pass them to direct 3D as VO, V2, V1. Maybe that is my problem. Yeah, maybe it really is this. But if it was really just the vertices, then wouldn't it just be flipping how they're being rotated individually? Like, if we run it, if it was really just that the indices were off, it would be flipping each one in its space, but it's flipping the entire thing. That makes sense? Like, if it was really just that, like, because each one of these has its own little, like, I mean, we can just look at it here. We can see that it's drawing a lot of different rectangles. And it's not just flipping them, it's yeah, it's not flipping the actual image. It's flipping the entire thing. I don't know. Model space is correct. Each quad is correct relative to each other. Something is wrong with the projection. The projection matrix. So our projection matrix is this, we say it's orthogonal. So when if I create this, and it's right at its feet. Maybe I should look at the spine SFML and see what they do. That might be a good thing. I didn't think about that. Spine run times. Let's look at the SFML. This is 3.7. So are they doing anything with... The thing about this is that they already have it all set up. The SFML has the matrix set up. Just draw the vertex array, append the vertex. Times the size, that's interesting. What's the size? Texture get size. Load. That all looks fine. Like, it doesn't look like they're doing anything special in here. Does this have rendering at all? I don't think so. I think you are expected to add your own render. Sine Unity. Ah. See how they set it up? Set to set up pose. Maybe I should do that. Set position, update world transform. Wonder if I should be calling that. Whoops, wrong thing. Probably should do it in component pool.cpp. Spline component skeleton set to set up pose. Maybe I should do that afterwards. Goblins, raptor, tank, vine, stretchy man, coin. This case. Interestingly, they pass in the scale whenever they load it. I'm not seeing anything that's like obviously the issue. This all looks fine. Vertex effect. Indices count. Look at the region, that's the thing that we're doing. Indices. Quad indices. Zero, 1, 2, 2, 3, 0. That's what I currently have, right? 0, 1, 2. 0, 1, 2. I did flip them around. Right. 0, 1, 2. Yeah, they're right here. 2, 3, 0. Yeah, that's what I have right here. Zero, 1, 2, 2, 3, 0. Rolled vertices. Set the size to 8. Yeah, this is pretty much exactly what I do. I make a vector or a float of 8, set it to 2. And then, where are they actually assigning it? World vertices. Oh, I see what they do. Never mind. This all looks the exact same. It has to be with how I'm setting up my projection matrix. That has to be it. Like, maybe I have it set up flipped around and then I did something to fix that. I kind of forget what. And it fixed it for the other thing and I can't remember what I did for that up here. Maybe that's what I should do, is look at what I'm doing up here. So I multiply this by this matrix here. Scale. Oh yeah, look, I translate it. Oh no, that's right. That seems right. Scale rotate, scale Y. I'm thinking if I can figure out what I did with this, then perhaps I can fix the other stuff. The vertices. And I'm like completely stumped on this. That's the far and that's the near. What did I do? I could always try doing something like this. Where I have this set up. I'm not saying I want to do this for sure, but I guess all I really need is the matrix scale, right? The model. Oh wait, I tried that, right? Didn't that fail? Yeah, that's right. The model matrix is okay. It's the projection. What the? Right? This is going to flip the position. Oh yeah. Well, the thing is that I would need to. That's it. Okay, maybe that's my problem. Is that actually I need to do a SRT, which makes this really hard. This can't be right. This can't be right. Ah. Maybe there's a someone has done something like this, like spine BGFX. Frag. For the NIM programming language, interesting. NIM. I don't know if I've ever even heard of NIM. Interesting. Stack attack. I think I saw someone developing an engine with BGFX and C++. I don't recall what it was. I'm seeing if I can find it. What was that called again? It was on GitHub. Just flip your V coordinate. He's talking about the texture. But that's the thing, is that I don't think it's that my texture is being flipped. It's that the vertices are being flipped, right? If we look at this, we can see that here's the VS in and this is the VS out. So it's not that if it was the vertices being flipped, then everything would be in the right place. It would just be upside down. Like his head would be he would be standing upright, but his head would be upside down. His legs would be upside down. His feet would be where his knees are at. Stuff like that. Or if his feet were attached to his legs, or it depends on how they're all set up. But yeah, all the textures would be flipped upside down, but the vertices would be in the correct place, right? That's what I'm thinking. But in this case, if we look at this VS out, we can see that it's actually just flipping everything there. One thing I'm not sure about it is it flipping it within the like how is it deciding it gets flipped? I don't know. Ugh. There's this guy, Fake Pyre or something like that. He was super helpful back in the day whenever I was working on this stuff. I wish he was around right now. He probably would know what the issue is. Yeah, you can actually see if you look at the R position, the input, versus the SV position. Like, look at this, where we have, like, we say it's at 233 or 232. And so that's at 0.22. And then we look at 206, and it's at 0.311. And so it's like that's a larger number, but it's smaller over here. So we can see that the vertex position is actually being moved. If we look at a much smaller number like 122, which is vertex 22, here it's at 0.59. It was like, we can see that the vertices are like way off. Did you use the same system for Korea? I used SFML for Korea, so unfortunately I can't really look at that. The display of picking the render target and the picking example is vertically flipped with OpenGL. I dedemmed to something like 120 and I found that the preview of the picking texture is flipped. When you render target, and you have to flip depending on the render. See the example doing it in here. Screen space quad. Origin bottom left. This is what he's talking about. Yeah. The temp is the MV, so he just flips them. So that's being used to set them in here. What am I using? I'm using BGFX. What render engine are you using now? Yeah, it's BGFX. It's SDL with BGFX on top. SFML is only creating the window. Right now it's set up to, wait, I think I left it with OpenGL, but we can do DirectX as the rendering backend. Doesn't seem like it's really making a difference here. So what if just this I wonder if the scaling is off too. Like, why is this so large? I don't get it. The min v. What is min v even? Yeah, I think again this is flipping the texture coordinate. If you look at that, like it's basically doing something like this, right? Oh, whoops, it should be this one. Yeah. So that's what I was kind of expecting it to look like if it was flipping the textures, where each individual texture is flipped, but all of the actual graphics are correct. I mean, sorry, the vertices are correct. Vertices are correct, and where it's like drawing into rectangles, but the actual UV, the texture coordinates are wrong. Nice, ship it. So it's like I need to flip the vertices, but relative to the, like, it seems like it's just flipping it in local space. That's almost what it looks like. I wonder if I could fix this by like rotating the like bone by 180. That'd be funny. Maybe. Just try that. You never know. Yeah, I'll try it. Where am I creating this? Here we go. Fine skeleton. Ooh, I think I need to get the bones. Get root bone there. That's it. Set scale X. Maybe I can just set the scale Y. Oh yeah, I tried that. It didn't work, right? Get bone. Get root bone. Scale rotation. Float value, local rotation. Let's try 180. I don't know if it's in radians or not. If this is wrong, we'll try pi. Hey, Mr. Poundsign, what's up? I must, we are here struggling to get this set up. Oh, whoops. I guess this return. Oh, what? Ahaha. I think I see what's wrong. Yay, struggling. Yeah. So we're trying to get the spine 2D animations to work. And struggle bus. Hey, he's now kind of right. It's actually flipping it up 180, but it's like completely flipped around. So how do we flip it so that he's actually Facing the other way. You know, it's really weird. I want to look at something. It's weird that they say that they have a flip X and a flip Y, but that doesn't exist here. I wonder if... Let's go look at this. Let's look at spine C and let's look at spine C++ and see if... Let's just look in here, flip in this repository. Flip mixer behavior. So there they have some stuff for flipping where they're looking if the scale is less than 0, then it's being flipped, which is basically what I was trying to do. Initial flip X, skeletal graphic. Oh, that's looking for everything. Ah, I see. Set flip. It's kind of annoying. I guess what I could do is limit it to C++. Flip V. Oh, what's that? Atlas. Oh. I did not see that. It's in Spine CPP. Why did I not see that in here? Flip. Oh, it's right there. So they actually have something built in for us to flip the V. I don't think that's going to fix anything for us, but we could still do it just to see. I think that's going to be what I was kind of showing earlier. Does Spine have full physics like ragdolls? Kinda. It doesn't have actual physics, but it has bone support, and so you can apply stuff to the bones, like forces and whatnot, to have like ragdoll physics, basically. So you can definitely have like ragdoll physics, or have ragdolling with spine animations. Okay, so we get the atlas. Here's the atlas. Let's just do this and say flip V. And let's just go into here. Yeah. We're just hacking it right now. Hacky hack hack hack. Seemed like a really cool idea. Yeah, it's pretty cool. Yeah, see, that's exactly what I got earlier. Flipping the V. Yeah, it's definitely not flipping the V. Flipping the V. I was talking to someone in a game the other day, and I was reading about slang. This is just I made myself think of this. I was reading about what is it called, like Gen Z slang. You know, the current slang that people are using, and it's crazy. Like all of the terms that they use seem so foreign. I'm like, man, I'm getting old. And one thing is like they talk about, instead of saying like money, they call it like bread. And so just as like messing around, this guy was telling me about how he trades cryptocurrency as his like main thing. You know, as his as I said, is that your main bread? He's like, yeah. I was like, I'm so cool. I was using some slang there, main bread. But yeah, Flipping the V. That's not actually a thing, but that made me think of it. I'm gonna be like such an old man. Like I just know, like, you know, in another 10 years someone's like tells me something cool and I'm like, sick, and they're like, you're old. We don't say that anymore. I'm like, cool, and they're like, don't you mean squiggly pooch? What am I doing? What am I doing? That's right. I was looking at the flip stuff. So they just have flip V. They don't have anything about flipping. Man. Main source of income, not money. Semantics. And what if you would flip the whole skeleton? Yeah, we can play with that too. Set rotation. So maybe I can set the rotation, spine, skeleton. So this doesn't have a set rotation. I don't get why I can't scale. Oh, whoops. Set scale. Well, that's just going to be overwritten, right? That just gets overwritten. I need to figure out how to do this stuff anyways. Yeah, I think I'm just overwriting it up here. We could try doing scale negative here. Negative to flip you? Why is that you? I'm worried Gen Z may be the most homeless generation yet. Yeah, maybe so. Yeah, see, now we can't see it, and then it seems like it's really large. I don't quite get that. It's like I can't actually scale it by a negative number. Like that actually just does not work. But how do I flip it? I feel like they just kind of forgot about that functionality. Do they call it something else in Spine C? Or do they have that or anything? Let's look at skeleton. Yeah. And bone. Set slots to set up pose. Set to set up pose. Update cache. Sort bones. I don't see how you can flip something. The scale. That's pretty old. This is pretty old. Any progress? Nope. I'm just stuck here. That's all editor stuff. We don't want editor. Flip, skeleton. How old is this? Yeah, I don't get what's going on here. Whenever, I guess we can try flipping it and see what it's trying to do. Let's get rid of that. And we will set the scale here to -3. So it tries to flip it, but it's going to be like completely off. Is Atlas the skeleton? Atlas is the information on where the texture data lives. It's kind of like the sprite sheet data. And then there's an Atlas page, which is the actual image, and then the skeleton contains all the skeletal data, and then the animation data lives inside of an animation state. Okay, so this is going to be like completely off right now. We don't know where it's at. We can't see it. Let's see what... I could see it still looked like it was off or something. Whoops. Yeah, it looks like they got rid of the flip stuff. I don't know, I might have to ask for their help on this. I'll try to figure it out. Does skeleton have a flip method? No. If we kind of look here, oh wait, it's right here. He says like scale is the right way to flip the skeleton, and will flip even bones that have inherit scale disabled. It is more powerful than flip X and Y was. It can cause slight differences, as you found with bounding box winding. You can check if the scale X sign is not the same as scale Y and reverse the winding. Maybe that's the issue, is the winding, and that's why I can't see it. That actually might be the problem. But let's open this up in RenderDoc and see what we get. Should be right here, draw index. Let's look at our pipeline vertex. Mesh output, that's what I wanted. So here's the, oh, hey, look. PSN and then out is upside right. I think this actually fixes it. But I think, like he was saying, the winding is off. Which is interesting, and I might have to like look at how to fix that. Yeah, so what would be the he says that the winding is off. I don't know exactly how that is. So we need to change the indices. I'm pretty sure that's what we need to do here. So does that, I think that means that we just need to flip these two. And maybe these two. I think that, so it just goes in the opposite way. So instead of like going like this, it would go like that. I think that's correct, is you flip the second two. Oh, whoops. One on there. Oh, OMG! I did it! Yay! Progress! So I had gotten it kind of right earlier with the flipping. Well, I don't know. It's weird that I have to flip it to get it in this correct state. And I had tried to do this, but I didn't realize like the winding was off, and so I had to change that. But whenever I click this, where does it set it up? Yeah, so that's its feet. So one thing I don't quite get is why is it... It seems like it's a lot larger than it should be. Use 20 FPS per guy. Why can't I always create them? That's weird. Oh, it's probably because I'm clicking on existing ones. Yeah, I mean, we haven't optimized this. There's actually a few things that I need to look at, but yeah. We're in debug mode, so that would make a difference as well. So I guess that's something I need to keep in mind with the indices is if we're flipping it, then things need to change. I think it was saying that if the X and the Y are not flipped. So like if we undo this just to see, we undo that, we go back to our game where we are flipping it. And we flip both, then I think it works. So he should be facing to the left now and is upright. So it's if the scaling is, if the signs are not equal, then we have to do it this other way. See, like that works. And if we take it off, so that they're the same still. Then that works, which is what we originally had. But if we only flip one, then it doesn't work anymore because I honestly don't fully understand it. It's with how it's determining the positioning of them, so we can't see them. It should be right here, but it's basically being culled because it's backwards facing. And so yeah, the fix is to I guess it would be to make it so that we need to like flip these. So like this is two and this is one. If I mean the cheap way to do it is something like I think the spine sprite. Wait, what is that called? I think it's the sprite, right? Yeah, the sprite index vertex count. But we don't have the scale. Can we get the scale with the skeleton? Get scale X. Yeah, so we could say if we want the sign. There's a way to do that, right? Like a nice, efficient way. That's with an int, but we have a float. I mean, this is the cheap way, simple way. Copy sign. Sign bit. Guess we could do that. Oh, that breaks. Kind of. Because, well, we need to be setting it there. That'd be the best way to do this. I guess to just move this up here. That's all. There's probably a much better way to do all of this, honestly. I need to go through all this code, I think, and clean it up. It's kind of ugly. So that technically fixes it. So now we can have it be flipped in whatever way and it works. So I think to get these all correct, draw the spine component. I actually need to inverse the draw order. While pushing them back onto the list. right? Seems really weird that I would have to do that. I guess the other way to do it would be here. To say while I is greater than 0, I set to that. Shouldn't that be -1? Is that right? I might be missing one. Yeah, I think I'm missing one. His mouth looks weird, huh? But that definitely is looking better. Shouldn't that be greater than or equal to, right? Because we want to include 0 as soon as we go negative. Oh wait, but size t is... Oh, that's a problem. Yeah. That doesn't work. Because... size t... It goes negative. Yeah, there must be a better way to do that then, right? I guess you could do it like this. Oh wait, that screws up everything though. Oh dang, I didn't even think about that. Okay, maybe I don't want to do it like that. Yeah, I'll also have to change this one. Is there a better way to do this? I don't typically do a negative iteration, like iterating through it backwards. There must be a better way. Interesting. That's kind of cool. R begin, R end. Missed the part of what we are iterating. The sprites. That's a cool way to do it unsigned. Yeah. That's cool. So that works. Edit cast unsigned. And I is equal to 10. I is not equal to data cast unsigned -1. I mean, that's just the max, right? Oops, size T. I think I had this wrong. He says not equal to 0. Oh yeah, that makes sense. I still think the scaling is wrong. Why, like, what's up with this bounding box? Why? Like, I think actually if I create a new one right here, oh, it does render it. Okay, never mind. I thought we were calling it, but I guess we don't. There, that's the last problem I would like to try to figure out right now. Scaling issue. I guess what I should look at is, let's go ahead and restart this so we only have one. What happened? Why did it not start? Didn't you scale it to -0.3 or something? Yes. Well, we can try no scaling, and it's like really large then. Yeah, I'll show you. That's actually probably would be best to put at 0 while we are trying to fix this. But we're making progress. We're like almost there where it's like working, and then we can actually start fixing up the code and cleaning it up because it is absolutely messy. Okay, so there's our big boy. I can't even see. So one thing that is interesting, so you see how big it is? It's like actually like bleeding, or I don't know. I think it's because it's so big that it's like acting a little funny. Very big, yeah. A big boy. So huge. Yeah, let me actually just, I was trying to get the rectangle to show up on the screen, but we can't even see it. Okay, so there's our big boy. Let's go to our, where's that at? Animation. Setting the X and Y, update the world transform. Is that what I wanted to look at? Thinking here. Well, actually, we'll want that. So we should re-enable that. Sorry, I completely got distracted and lost my train of thought. What is it that we're setting the scale? I guess what we want to look at is like how the bone is being set up, and probably actually more interestingly right now is our entity layers and how it's calculating this stuff, our bounds. Let's look at that. Wait, what? Revert. Oh, we get. So this kind of. Oh wait, what's our vertices length? Get the bounds. Oh, I see. That's for the first one. Yeah, and then it figures out the min. Wait, do we clear that then or out? I 0 vertex length. Vertices length is 8. That's the 8. Why do we have to do that? That's so weird how it wants us to pass that in. I guess so that way we can just create it and it just can reuse it. Only thing I can think of. Min X, min Y. Okay, so that actually seems pretty large. Get the bounds. So it's 492, negative 143. the width is 388 and the height is 731. That actually seems right. So maybe it's the shape that's wrong? Oh, I know what the problem was. It's that we are applying the scale twice. Okay, so actually it looks like it was right. I don't know why it's so big. It seems like crazy large, but I understand this now. It's because this really should just be 1. The reason for that is that whenever it's figuring out the bounds, since we are scaling it already, it gets scaled, yeah. Okay. So let's actually set this to like 0.2 because it's so large. Whoops, I accidentally closed the game. Nice. That's perfect. Awesome. We did it. We fixed it all. Banzai. So one thing that's a little weird, sometimes you'll see it pops up and it looks weird. It's because there's a frame where it might not be running our animation system since this is time stepped. It might not run this for the first frame that thing is created, right? Because, well, wait, where are we creating? Oh, yeah. It's because we're creating this before we run, I mean, sorry, after we run our fixed time step. So we probably should do this, the fixed time step, afterwards, huh? I'm gonna move this up here. This could still technically have that problem though, because yeah, like I guess what we should do is at the time of creation also set up this other stuff. The game is ready then. Yes. Oh, whoops. I meant to keep that. So like we technically kind of want to do this stuff whenever it gets created. Right? Yeah, I don't think we're applying the skeleton to the state until afterwards. Apply. I wonder if we actually want to be doing this here. I think so. It might be the case that we kind of don't really want this to be running inside as an actual update here. Like maybe what we really want to do is not have it run. Yeah, that's tricky. Like right now it gets called here in the fixed time step. If you have less than 60 frames per second, then you're not guaranteed for the fixed time step to run before it renders it. Right now we kind of do R because we have such a high frame rate. Well, actually, no, we do. Right. Actually, sometimes I still see it kind of large. I don't get why sometimes it doesn't let me create another one. Ooh. So yeah, we could definitely profile this and see where it's spending a lot of its time. Another one. Okay. Okay. Excuse me. Wonder if there's something else I'm missing about that. I think we should. What are you coding? I'm coding this game here. Dig. I think we should commit everything that we have so far, which is a lot. This is all support for spine 2D animations. It's a lot. It lasts like 3 days. I don't think I need that thing though. I turned that on, but it's not working, so we'll discard that. That's a mess. But before we clean it up, I want to commit it. What's all of this? I don't remember changing physics stuff. Okay, so we want all of that. And we'll take the example stuff here and spine texture loader. We ended up getting rid of that. Remove. Okay. Spine. I think I already did the spine loading, so this is rendering, yeah. Added support for rendering spine animations needs to be cleaned up. Okay, cool. So yeah, one thing I'd like to see if I could figure out is getting this working nicer. I think I probably had it working, but the stride was off. Remember we had the stride where I thought it was 24, but it was actually 16 because I was creating that thing wrong. So I'm going to try to go back to doing it this way where, wait, we don't need this mem cup. What we want to do is say that this is, it's actually more like what I did up here, right? The start vertex. Say, okay, this is the start vertex. We can give it position 0 and the offset 0 there. The stride is 24. And then that would make it so that we would not need to set that up. Let's do that. We do have to set the Z to that. And then also set up the text to coordinates. So we'll see if this is working. Dang. Can't see it. Let's see what the position is. If we break into here. 38 to 42. Yeah, it doesn't set it properly. So what is it thinking that this is? Maybe it doesn't realize that this is a float pointer. It should be. Well, it wouldn't be right. It wouldn't compile correctly if it wasn't like that, right? Or it'd be complaining. Yeah, it's like it sets the first one right, and then subsequent ones are just off. Which I don't quite get. We'll take a look at this once more. The stride is 24. Oh, wait. Oh, that's right. The stride should not be 24. It should be 6. It should be size of divided by the size of a float, right? Whoops. That's my problem. That's my problem. Aha! Nice. Cool. We fixed that. Dot data. This is not a vector. This is a float pointer. We honestly might not need to do that. I think what I could do is just change it to be a float pointer and do this. So that works. Cool. Yeah. I mean, it's the other way made it so I wouldn't have to do that cast. But really what we're just saying is like, hey, treat this, since the stride needs to be of a float, like that's what it's expecting. Yeah, so that works. Cool. Finally understand that. So that makes it so we can get rid of that stuff. We still need to set up the tinting. I wonder if they're... No, that wouldn't quite work. Never mind. Okay, so we got that. I don't like this sign bit thing. We'll clean that up too. So let's see here. This vertex, that's what I do there. Let's start vertex plus J. I think that's okay. We technically don't need to do that inside of there. Okay, whoops. We do set up the start vertex outside of it. Good. Okay, yeah, so we have start vertex. I thought that was inside of this. And so then this, yeah, we can just say it's a float pointer. And it's a size of divided by size of float. This is always 6, right? That's the stride. That's a little bit better. Overall, though, this code, I like to figure out a way to, I think, refactor this because we do this so many times now. This, like, submission thing. There's also this code here. There must be a better way to do that. Can we initialize this up here? And then set it like that. Does that not work? Question must be a modifiable L value. So if you create an array like that, it has to be initialized immediately. That's what it looks like. That's something I'm not super familiar with. Like, I know I could set... I guess that's because this is an initializer, and so you can't do that because it needs to be initialized. Yeah, that's what I was thinking. Is there a better way to do this? Because all that we need to do is we change around what the minus are. This is like super ugly. I wonder what we can do for that. Let's profile this. I want to look at what's causing the frame rate loss. Make an inline function that takes 6 params. Yeah. So we'll create a bunch of these dudes, which will drop our FPS significantly. And then let's enable CPU profiling. So a large percentage of it is draw. Render. Sort the layers. That's 40% of the time is spent in here. A lot of it is spent in draw. Pushing back this spine sprite is taking up a lot of time. Yeah. Because we're creating a new one for every single one. Yeah, this is bad. Would be a better way to do this. Group UID. Yeah, it's because this is a hash map. Yeah, I think that we probably just need to come up with a better solution for that. So I would say that it would be interesting to see the FPS in release. Yeah, I bet it's a lot better because I imagine a large part of the time spent here. Yeah, we can kind of see unordered map, like 15% of the CPU time is spent just trying to do this right here, this group UID. So that's most of the time in that function. And then it also is spending a good amount of time within this get bounds. Is there a way to like step into that? Oh, right there, called functions. There, it's computing the world vertices. So it's it's actually spending a good chunk of time in here. This is interesting that this actually is instance of spending 5% of its time in there. Compare class. Oh, it's because it's comparing a freaking string. That's dumb. Okay, we need to fix that. That's really stupid. No. This RTTI thing is actually not good. So they make it so that they want to avoid the RTTI by having this own RTTI solution. But you have to compare string, which seems like that is not good. One possibility that we could do is turn this class name into a hash string, and then it would be very cheap. Let's look at that. The RTTI. Class name RTTI. Right, like what if we just get class name? So that's a bit, well, we could leave that. What we could do actually is have a const UN64. We'll make it a UN64 just so we don't lose it, and we'll call this our class ID. This does not follow our naming scheme, I know. And then if we did this class ID, that would work. Class ID, your class name, that's okay. Is instance of class ID. Anywhere we compare it, we should do that. And then the class ID is just the haster 64 of their class name. Right? Last name Cster. And I need to include utility haster or hastring, yeah. That should work. Oh, I need to do it up there too. There's 64 not found. Oh, that's in Siege, right? Plebs? I don't know. I don't know why they did that. So we can see if this is an improvement. We can look at how it's doing that. I imagine it is. I'd be very surprised if it's not. Yeah, all of that has to be recompiled. All of this bind stuff, because it all uses the RTTI. Okay, so we can, I guess, just create a bunch. Do the same thing we did earlier. I mean, it shouldn't really make that big of a difference because it's still all relative. No, I haven't messed with that yet. Context swap. Render, yeah. Good to draw spine entities. Here we go. If we look at this get bounds, then we look at this, look at that. The get RTTI instance of 0.4%. Before, it was like 4.5%. So we just cut off a ton of wasted effort there. And that's also, we were doing that in multiple places. Like, it was happening here in the draw spine entities. Or sorry, where was it? It's inside of get bounds, it would do it. If we go back, skeleton get bounds, layer, draw entities. So that drops some. Our draw function is still taking up a lot. Oops, go back. And the majority of that is in here, the unordered map. It's also doing the allocation. So like one thing we could do is resize the this, right? Oh, I guess we don't know exactly how many we're going to have in there. Are you 100% sure your batching is okay with spine? I mean, yes, it's, well, is it working completely? I don't know. We need to create, or we need to get a spine that has multiple atlas pages to test. So that way they aren't being batched together. So we would have two separate group UIDs. It's something I need to play around with. But yeah, all of this should be batched properly, and we could break on it and see. Well, we could just look at the draw calls inside of render doc. Can't that be in place back? Yeah, we could try that, but I don't, that's not, yes. That might help a tiny bit, but the biggest problem here is this unordered map. We just need to replace our not vector, our yeah, sorry. We just need to replace. Man, lost my train of thought completely. Yeah, sorry. We need to replace our unordered maps to be something else. Not standard library, but maybe like, I saw there's a K-hash or Google dense maps or something like that. Replace it because the standard library hash maps suck, apparently, and they're especially bad in debug. And so, yeah, we could replace that. So this draw function is taking up 25%, which is all draw spine entities. 16, 5. So yeah, that's still taking up a lot. I guess that's, out of that 16, most of it is that submit layer. Man, this is so nice, this debugger. Yeah. It spends some time there. Compute world vertices. That's where it spends a good chunk of time. Yeah, pretty much seems like we need to just get rid of our map. That's like one big thing. So that's nice that we actually were able to like figure that out and fix it. I think we fixed one big issue with the RTTI thing. I don't really know what they're thinking with that. Maybe they just didn't consider using a hash map or the cost of comparing strings all the time. Profile part of the DIG tool. What's the name of that tool? Yeah, it's built into Visual Studio. I'm using VS 2019. But yeah, it's really nice. Like, amazingly nice. Being able to do that. So yeah, let's spawn 50. It's weird that I have problems spawning them up over there. I think it's because it's like thinking that they're, I don't know what's going on with that actually. Okay, there's 50. So our frame rate is about 55. Pretty even, 55. Yeah. So now let's try release mode. Is that where your UI is hidden? Oh, you know what? It might be. Good thinking. I completely forgot that I'm just not trying it. Good thinking indeed. Yeah, I completely forgot that was there. Yeah. You just have to wait for it to compile. We could probably honestly fix up this RTTI even more. Probably prevent copying. Let's see. Simple no parent. Simple. Is that just used throughout all of these? Yeah, so that's the name RTTI impl. The spine name parent RTTI. What I was kind of wondering is if you could instead make this be a const expression or something like that. Probably could. So then all of this could be set up during compile time. Hey Wes, what's up? Taking a break from a jam, nice. Which jam are you participating in? Okay, so here is our release. So we'll create 50 dudes. So with 50 guys, our frame rate looks to be about 950. Average 950 around there. Sometimes it dips. I wonder why it dips. Yeah. So it's not too bad. But I mean, that's all it's doing. So. Yeah. My goal is to keep debug at 30 FPS, which is completely playable. It was 50 a bit ago. What changed? Went from debug mode to release mode. So debug is not optimized whatsoever, whereas release mode is very optimized. Yeah, and it's especially with the standard library containers like a vector and hash map, whatever. Those, from what I understand, are very bad performance wise in debug mode, and so they really hurt debug. But yeah, we could probably look at fixing this up, making it be a const expression. I'm not exactly sure. One thing I'm a little worried about is I don't want to change too much of this, because if I ever want to update it, it's going to become a pain. And it's already going to kind of be a pain to update. Maybe if I could just update that one file or something. Yeah. Be interesting to make these changes and then suggest them. It's like, hey guys, here's a way to get, like, with the RTTI, just like by doing that one change where we have it comparing the hashed version, it's like 95% faster. Hey, yes, exactly. Yeah. So what would that take to make it be? Let's look at something like our animation state. Does that have our TTI stuff, or like how is that being set up? Spine object. The spine object. Okay, yeah, that's just the new and delete operators. Sure. To look at like something that definitely uses skeleton. Yeah, so it looks like I'm not seeing it being used anywhere else. Wait, where's the RTTI in here? RTTI. Maybe they don't do it in here. Okay, let's go look at like the attachment. So this has, yeah, that's what I was looking for. The RTTI decal. So there's the declaration, and here's the implementation. So the problem with this current solution is that, and probably one of the things that they wouldn't like is that they want to do C++ 03, and I'm using like C++ 17. Hey, JChemist, what's up? And so this, if I wanted to make this be a constant expression, I think I'd have to like change it so that the implementation is actually included in the declaration, because you have to have the, like, it has to be all up in here. And okay, RTTI, return the RTTI, which is the class. So we're gonna have to make the RTTI be a const expression, right? That's basically what, yeah, that's what we're gonna have to do, is make RTTI constructor be a const expression. We could then actually do a lot of that. Like, I think we could make the bool an instance of be const expressions as well, I think. But yeah, it would require substantial change to this system. I don't think I want to do that right now. Yeah. Well, it would mean that everywhere that we use this RTTI decal, that would have to change, which is in 34 places. And then all of these RTTI impls would have to also change. Well, we would get rid of those basically. We'd be merging the impl up into the decal. Which might make things kind of weird and awkward. No, that should be fine. That's just the name. Explicit. I think that's how we would have to do it. I'm curious how this would work. decal const expression. Const expression. So there's the get RTTI, which returns that. Why can't we just have it be a return RTTI? Make that be a const expression as well. Why would it need to be virtual also? I don't think it needs to be virtual. Isn't that weird? Like they're trying to make it so that, oh, it needs to be virtual so that the correct one is called. Isn't that using the RTTI then? Right? I don't know. Maybe I don't know enough about this. I think I might not know enough about all of this. Base. Yeah, maybe I won't mess with this. I don't want to mess with that. I take it back. I am actually curious about this. I'm going to read into this whole like adding in support for your own RTTI. Yeah. So yeah, we made some good progress today. I think I'm gonna call it a stream though. So we were able to accomplish what I was hoping we could do, which is go through all of the issues that we had with the rendering for Spine 2D animations and fix them up. We were on the struggle bus for quite a while, but then we had a nice breakthrough and we're able to just kind of like plow through the remaining or the issues once we fix that first one. And yeah, so it's looking good. We have our little dudes walking and it has the bounds perfectly working. There are some optimizations that we can make to this. Like right now we are recalculating the bounding box multiple times. We could probably cache that somewhere or something, so we're not having to recalculate that. We saw inside of the profiler that is taking up a good chunk of time. This what is it? I think the get bounds. Yeah, get bounds, which is also calling like compute world vertices. Like that's happening multiple times. And so we could clean that up. Like we're calculating it here to get the bounds for this shape. This is something temporary. We're also calculating it down here to determine the actual like if it should be rendered or not, if it's within the viewport. So we could fix that. Like I said, yeah, maybe caching it or something, because we probably want to use that bounds for many things. Like maybe what we want to do is, yeah, actually I'm not sure about that. I don't know, we'll need to look at that, figure out the bounds, because I think we'll need, or we will want to use the bounds for many things. Like let's say if we're wanting to figure out if something collided with another entity, like if we had two spine entities that could possibly be colliding or overlapping or something, it would be really nice to be able to just check the bounds and say, hey, do these rectangles, their bounds rectangles even overlap? If they don't, then we know that there's no possibility for there to be a collision. And So yeah, I think that it would be good to cache that somewhere. I'm not sure where we could maybe put on the transform component. The problem with that is that we're using the transform component X and Y to set where the bone is at. And we'll do that inside of our animation TPP right here. And so we don't want to be overwriting that. So it's kind of weird. Maybe we need to come up with some other thing. Like maybe we put it on the spine. I don't know. I don't know where we want to put it. Where it makes sense. That's something to figure out for another day. But yeah, so we made good progress. I will be back tomorrow. I don't know when exactly. It's either morning or afternoon. Yeah, I'm not sure what my schedule looks like tomorrow. But I'll be back tomorrow nonetheless. And we will be working on... I don't know, actually. I think we might be done with the spine animations. And we can move on. I'll look at that. So yeah, I hope you all have a good rest of your day, and I will see you tomorrow. Take care.